Welcome to the Geologic History of New York State video. For this video, you are going to need your Earth Science notebook and your Earth Science reference tables, pages 8 and 9, and obviously a pen or a pencil. If you're watching this without the volume, make sure you turn up the volume. I'm going to be saying a lot of things that you need to hear. Let's start off by setting up your notes. You should write this on page 43. Make sure you put the title, which is Geologic History of New York State. Whatever date you are doing this on, you can put that date on that page as well. And then you want to also set up your table of contents. There won't be a lot of notes that you're writing on page 43. Most of what we're going to talk about today comes from your BFF, your Earth Science reference tables, but this is something you do want to write down. So the geologic time scale is really what we're going to be talking about today. And this divides Earth's history into sections of time. The longest period of time is going to be the eon. And so you can see if time starts at the bottom, which we know the oldest layers are always at the bottom, and goes all the way up to the top, this eon takes up a really long time. And this is called the Phanerozoic eon. This is actually the eon that we're in right now. The second section of time then is an era, and eons are divided into different eras. So you can see here that the Phanerozoic eon is divided into the Mesozoic and the Cenozoic era. We are actually right now in the Cenozoic era of time. Each era is divided into periods. So the Cenozoic era is divided into three different time periods: the Paleogene, the Neogene, and the Quaternary. And then each time period is divided into an epoch. And epochs are the shortest time periods, so they don't last very long. For example, the Quaternary, which is what we are in right now, is divided into the Pleistocene epoch and the Holocene epoch. The Holocene epoch is what we are in right now. So if we go to our Earth Science reference tables, we can actually see all of these different time periods, eons, eras, and epochs right here at the top of page 8. So here are the eons, the eras, and periods, and the epochs. And so we're going to take a look first just at the eons, which is all on the left-hand side of our chart here that I've highlighted in blue. And this is a time scale that starts at the bottom, right down here. This is the oldest, this is where we'd find the thing that is the oldest, right, the longest time ago. And we can see here that this is the Earth and the solar system origin, 4,600 million years ago. So this number here is 4,600, and we know that this is in millions of years ago. So that's actually 4.6 billion years ago, or BYA. I would go ahead and write that in your BFF so that way you know that that's how long ago the Earth was formed, as well as the rest of the solar system. So if we start here at the bottom, you can see that this is the Precambrian eon, and the Precambrian eon is divided into kind of like sub-eons. We have the Archean and the Proterozoic, right? So this is all we call it the Precambrian eon. And the Precambrian eon takes up the majority of the time that we've had here on Earth. Probably 85% of the time on Earth has been in the Precambrian time period. And very little time that we know of has been in the Phanerozoic eon, which is what we are in right now. And what's interesting about this is we don't know a lot about what happened during the Precambrian time. And there are two main reasons for that. Number one, we don't have a lot of rocks left from that time. Most of those rocks have been subducted back into the Earth's crust and the Earth's mantle by plate tectonics. So if we don't have the rocks, then we don't have fossils to be able to tell us what was going on back then. And number two, most organisms alive during that time were probably really soft-bodied. They were squishy, and so they didn't get preserved as fossils. You don't get any fossils if you don't have bones or shells or some other hard part that is going to be preserved as all of the sediment buries you underneath all of the sediments and rocks. So no fossils, no evidence of what life was like during that Precambrian time period. And we call this the Precambrian eon because it took place before the Cambrian. Here's the Cambrian time period, right? So here's the time period. But even though this is the Cambrian time period, pre all happened before it. And if you follow this area up here, the boundary between the Cambrian and the Precambrian is this bold line right here. So everything that we know about what is happening on, or what has happened on Earth has taken place during the Phanerozoic eon. And basically that's all of this information here between these two red lines that I've drawn in the BFF. All of this information here squishes into that Phanerozoic eon. So we know a lot about what has happened since about 540 million years ago, but we don't know a whole lot prior to that. And the reason for that is, for some reason, 540 million years ago, and I know it's 540 million years ago because it tells me right here, this column right here is like another time scale that tells me how many millions of years ago things occurred. And at that point in time, for some reason, we suddenly see a ton of fossils in rocks. Sometimes people actually call it the Cambrian explosion because it's like, oh my gosh, suddenly all of this life suddenly exploded onto the planet. That's not probably really true, but it just means that all of the organisms that were on the planet suddenly developed hard shells or bony pieces that could now be preserved in the rocks, and now we can see that in the rocks that we study. Okay, so let's zoom in and take a look at some of the things that actually happened during the Phanerozoic era. It's divided into 3 eras. So here's the Phanerozoic, I called it an era, it's actually an eon. So it's divided into the Cenozoic era, the Mesozoic era, and the Paleozoic era. And then each era is divided into these time periods. So students often ask me, why do we have these different time periods? Like, what makes the distinction between them? Well, those boundaries between time periods represent changes in the life on Earth due to evolution or mass extinctions. So if organisms are changing, then if they've changed a lot and you see completely different species or maybe even completely different groups of species evolve, then we would distinguish that's like a time where, okay, suddenly now we have dinosaurs that are abundant, that you have a lot of dinosaurs or you have a lot of mammals on the planet. And so that represents a boundary between different time periods. Likewise, mass extinctions. If you have, for example, all of the dinosaurs becoming extinct, at the end of a particular time period, we call that the end of a time period. An extinction is when an entire species dies out. So for example, the earliest dinosaur fossils are found in the Triassic period rocks. So if we look in the life on Earth and the time periods, we find Triassic. Here's Triassic. And if we look for under life on Earth, we can see that the earliest dinosaurs showed up in the middle to late Triassic time period. The late Triassic time period is up here, and the early Triassic period is down here. Remember, time is starting here at the bottom and going upward. So it's kind of weird to think about, like, this is when the Triassic time period started, and then this is where the Triassic time period ended, right? Because we're going up in time. And then we find abundant dinosaur fossils in the Jurassic period. That word abundant just means a lot. So we have a lot of dinosaur fossils in the Jurassic period rocks, which is probably why they call it Jurassic Park. That's when we had a lot of dinosaurs on the planet. And then at the end of the Cretaceous period, the dinosaurs begin to die out and eventually they become extinct. So we have this mass extinction of dinosaurs, and not just dinosaurs, something called ammonoids and also many, many land plants. and that's at the end of the Cretaceous period. And this happened 65.5 million years ago. And again, we know that because here's that time scale right here. There's lots of information here in this Life on Earth column. Pause the video and just read through all of the life that has existed on our planet. It's really pretty amazing. We have earliest insects, we have coral reefs, amphibians. So just take a moment to read through all of that. All right, time to check your understanding. During which epoch did humans first appear? And about how many years ago was this? Okay, hopefully you got that question right. You should have seen humans right here in our Life on Earth column, and that happened during the Pleistocene, and that was at least the Pleistocene started 1.8 million years ago. All right, here's your second chance to check your understanding. What major geologic event occurred at the end of the Permian period? All right, hopefully you got that one right. Here's the Permian time period. And if we're looking at the end, remember the end of the Permian should be here at the top, 250 million years ago. And this is when we had mass extinction of many land and marine organisms, including. The last column on page 8 is the New York rock record. This shows us when the rocks were deposited in New York State. For example, rocks were deposited here during the Pennsylvanian time period. Sometimes we call it the Carboniferous time period. We can also see that not only is it showing us where bedrock is, it's also showing us where the sediment is located, or at least when that sediment was deposited in New York State. All right, let's check your understanding about that. Were rocks deposited in New York State during the Permian time period? And hopefully you got that one correct. Here's the Permian time period. And if we follow the Permian time period over here, we don't see any bars that show up in there. So that means that no, there were no rocks deposited during the Permian time period. Here's a second chance for you to check your understanding. During which geologic time periods was sediment deposited in New York State? All right, hopefully you got that one. If we look at sediment right here, the only time we have sediment deposited in New York State are in these two areas. And if you follow those straight over, that would be the Quaternary time period and the Cretaceous time period. So hopefully you got those right. Okay, we're going to take a look here at page 9 next, but the only column that we're going to look at is this time distribution of fossils, just to save us a little bit of time in this video. And if we zoom in here on that column, it says that these are important fossils of New York, and that the center of each lettered circle, here's a lettered circle here, indicates the approximate time of existence of a specific index fossil. For example, fossil A lived at the end of the early Cambrian. So let's go down to the bottom of page 9, and we see A. Here is fossil A, and we know that it lived during the Cambrian time period. And if you want to know what fossil A looks like, you have to go down to the bottom of page 8. All of the index fossils are down here at the bottom of pages 8 and 9. And fossil A is all the way over to the left-hand side of page 8. And I've kind of enlarged it here so that you can see what it looks like. It's called Elliptocephala, and this is a scientific name, which are international names. They come from Greek or Latin roots. The word ellipto means oval. The word cephala means head. So the scientists that discovered it probably named it that because it has an oval-shaped head. And Elliptocephala is one species of a group of organisms that we call trilobites. So if we look at this bar that fossil A is on, it says trilobites. And these trilobites as a group of species, they lived from the Cambrian time period down here about 540 million years ago, 542 million years ago, to the end of the Permian right here, 251 million years ago. But the Elliptocephalus species itself survived only for a short time period right here in about the early to mid Cambrian. And since they no longer exist on our planet, we have this lovely artist's depiction of what these trilobites probably looked like when they were actually around. I look at them and I think to myself, ooh, underwater cockroaches, which is what a lot of scientists describe them as. So they lived in shallow waters. For example, like off the Bahamas, the really blue, beautiful blue waters, you would have found a bunch of these things around. And they ranged in sizes. Sometimes they were as big as your hand. A lot of them weren't any bigger than your pinky finger. Some of them were even smaller than that. All right, time to check your understanding. McClurites is an index fossil that can be found in New York State. To what fossil group does this belong, and during which time period did this fossil exist? All right, hopefully you got that one correct. McClurites was fossil W, so you had to find W on this chart, and I found it right here. So as I look at this bar, I can see that it is a gastropod. And since this particular index fossil, McClurites, was only found here, it only existed here, if I follow that straight across all the way over to page 8, I would see that it survived only in the Ordovician time period. And we still have gastropods here today. They have not gone extinct. This is a perfect example. Little snails are gastropods. All right, let's give you a second chance at that. Centroceras is an index fossil that can be found in New York State. To what fossil group does this belong, and during which time period did this fossil exist? Okay, hopefully you got that right. If you found Centroceras, it was index fossil F. So when I come over to my table, my Earth Science reference tables, here's F, and I see that it is part of this bar, and if I follow that all the way up, I see that Centroceras is a nautiloid, and here's a picture of what a nautiloid probably looked like back in the day. And if I follow F straight over to page 8 to see the time period that it existed in, that was during the Devonian time period. Centroceras and these nautiloids are related to the squid and the octopus. So you can see that it's got these little tentacles, and then it had this nice protective shell, and that's what's preserved in the rocks. All right, you're done. Great job. Just remember to bring your notebook to class to get a stamp.